All right, so we're doing 2 lessons today. One of them is labeled 4.1a and the other one is labeled 4.1, and we won't get into details. So there's going to be some overlap. I'll just skip over that in the second lesson. So technically these are both 4.1 though. So first of all, a lot of this is going to be review. Polygon, you already know what's a polygon. It's a closed figure made up by segments that intersect only at their endpoints. The reason we're covering that is because a triangle is a polygon. This whole chapter is on triangles. All right. Triangle is a three-sided polygon. Now, the classification of triangles is done by angles and sides. All right. Angles, you have a right triangle, all right, which only has one right angle. Acute triangle, all right. Every triangle has 2 acute angles. So to be an acute triangle, all 3 have to be acute. Obtuse triangle only has 1 obtuse angle because you literally can't have 2 because they have to add up to 180, and obtuse means greater than 90, and that would be impossible. And then equiangular, all right. Equiangular, all 3 angles are the same, meaning all 3 angles are 60 degrees. All right. You can sort of see where I attempted to draw them ish near each other. But so guys, that is classification by angles. Yes, an equiangular is a more specific type of acute. All right, because 60, all 3 are 60, all 3 are acute angles, but I'm not going to ask you that. All right, now classifying them by sides. So every triangle gets classified by angles and sides, and no, I do not care which one you write first. All right, so there's 3 classifications by sides. Equilateral is automatically equiangular, and equiangular is automatically equilateral. They those two go together automatically. Okay. So 3 congruent sides, guys. The reason for this is there is a direct relationship between the number of congruent sides in a triangle and the number of congruent angles. 3 congruent sides means 3 congruent angles are going to be there. 2 congruent sides means 2 of the angles are going to be congruent. No congruent sides means no angles are going to match inside that triangle. Okay, so equilateral, that's why it automatically goes with equiangular. All right, isosceles has, now listen, at least 2 congruent sides. So technically all equilaterals are also isosceles. Now, am I going to be trying to ask you trick questions like that? No, but can I promise somebody else won't? Also no. So I thought I would go ahead and tell you that. Equilateral is a more specific type of isosceles because isosceles says at least 2 congruent sides. I will just expect you to do the most specific type. Okay, so I would not expect, like if I gave you this top triangle, I would not expect you to say equilateral, equiangular, acute, isosceles. You would just say equilateral, equiangular. Okay. Then finally, and once again, isosceles is going to have 2 congruent sides. I'll go ahead and tell you those 2 congruent sides are going to be down here. They're called the base. And then scalene. Scalene is no congruent sides. All right. And then if you look at this one, obviously or hopefully you would be able to go ahead and classify the triangle by the sides and angles. Go ahead and do that. All right, go ahead and do that. All right, hopefully for the first one, you wrote down equilateral and I don't know if I spelled that right. We'll pretend I did. Equiangular. This one is going to be isosceles and acute. All right. Once again, if you put acute isosceles, I'm not going to mark that wrong because it's not wrong. I just tend to put sides first. It doesn't matter though. Okay. All right. So that's classifying triangles. Now, guys, just so you know, this is really just covering back to basics, just making sure we're all starting off on a clean slate. Vertices. So the vertices of that top triangle are going to be D, E, F. When I'm talking about adjacent sides, guys, adjacent angles share a common side. Adjacent sides share a common vertex. All right. So like side ED and DF would be adjacent. All right. They're just going to connect at a point. All right. That's really simple. You're not going to get like quizzed on that. Now, the rest of the stuff you really do need to know. It's going to make your life a lot easier and you won't miss problems. Right triangle, they're called the two legs always make up the right angle. They come together to form the right angle. And then your largest, longest side, the C, is the hypotenuse. And then, like I said, your isosceles triangle is made up of leg, and then a base. Guys, like I said, the base is where those two congruent angles are. They're called base angles. All right, that's because they are the angles that are with the base. So base angles on isosceles are congruent. Now, triangle sum theorem. Another thing you might see is triangle angle sum theorem. Guess what? They're the same thing. Apparently, some people don't understand whatever. I'm going to keep it as short as possible and just call it the triangle sum theorem. It's basically saying that all the angles inside a triangle have to always add up to 180 exactly. All right? How do we use this? We use it by, if we know two angles, we can easily find the third. All right, so here we go. Triangle RST is an isosceles triangle. Triangle R is the vertex angle. All right, now, guys, listen, isosceles, vertex angle, that means it's not the base angles. So that's how you know vertex angle is, there's vertex angles and the base angles. The base angles are always the same. So, and then it tells you what I've already labeled on the triangle, so I'm not going to reread that to you. All right, so go ahead, think about what you need to do to find X and solve for that missing stuff. If you know what to do, go ahead and start doing it. If you want to confer with somebody, that's fine. All right, obviously, in order to solve any of this, you first needed to solve for X. Who can tell me what they did to solve for X? Jake?
So you said 3x minus 5 and x plus 7 equal to each other.
Good job. So I'm going to set 3x minus 5 equal to x plus 7 because isosceles triangles have at least two sides congruent, and those two sides are marked as congruent. All right, so I do some algebra cadalgebra, and I get 2x equals 12, and then I get x equals 6, and then I am rolling. So you can put it in either one of these problems back in and find that side. I'm going to put it in the easier one always because I am lazy. So if that's 13, I'm not plugging it in that one. I know it's 13. I trust my math. If you don't, plug it in. If you don't get 13, something's wrong. All right, your x is wrong. So it is a good way to check yourself, but I just happen to know we're right. All right, so you would get 13, 13, and 5. All right. Now, if I asked you a question like this, guys, please don't make it harder than it is. You would not need this triangle to even be graphed for you to do this. But if I gave you a triangle and I gave you the vertices, use the distance formula to show that it's scaling, guys, just do enough to get the job done. So for instance, I need the distance of DA, I need DR, and I need AR. Okay? Wee. 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 All right. So from D to A, 2 to 4, my change is 2, so that's going to be 2 squared plus 6 to negative 5. Oh, boo. My change is 11, so that's going to be 11 squared. All right. D to R. 2 to negative 3 is going to be 5 squared plus 6 to 0 is going to be 6 squared. A to R. 4 to negative 3 is going to be 7, so 7 squared, plus a negative 5 to 0 is 5 squared. All right, you can tell all these are not going to match up. But if you don't believe me, 121 plus 4 is the square root of 125. All right, 36 plus 25, oh God, 55, 61, yay. And then 49 plus 25, so that would be 74. And none of those match, all right? So did anybody have a question about how I got the distance formula numbers? Because remember, I was just trying to find the change. So I just said, like, from A to R, the change in the x's from 4 to negative 3 is down 7. But because we're doing distance and distance is never negative, I just ignore that. Okay, so guys, that's 4-1A. Now, you're going to see a lot of the same stuff in here because I accidentally sliced them in two, so we're just going to ignore this. Once again, triangle angle sum theorem. Spoiler alert, it's the same as triangle sum theorem. I'm not going to refer to it with an extra word. Now, here we go. So, let's look at this. Guys, we're proving the triangle sum theorem. One easy physical proof is, this is for, I wish I had a piece of color paper. I do. Yay me. If the easiest physical proof for the triangle sum theorem is if you have a triangle, that's not even a triangle, it's not a straight line, but whatever. If you have a triangle and then you tear off the ends like so, and then if I put, you're fired. Then if I put all the tips, so I did this way too small, but if I put all the tips, like, so if I take all the vertices, all right, if I could take vertices together in a straight line. All right, you would see that it makes a straight line. And what is a straight line? 180 degrees. So that is the easiest physical proof of the triangle sum theorem. So if anybody ever asks you to solve that but they don't specify, don't do that with me. But I'm just saying. But that is the easiest physical proof. Now, the other proof, basically, guys, basically, given triangle PQR, then we're going to draw a line TW through P parallel to RQ. Anybody know what that line is called? You're not wrong. You're just not right. It's dashed. It's in addition to. We've talked about this. Auxiliary. It is an auxiliary line. That is a dashed line that is added to a proof. You will definitely need to know that, guys. Just because I don't make you do them doesn't mean you don't need to recognize it. So, guys, why can I do that? Because of the parallel postulate. It's saying that I can always, if I have a point that's not on a line, I can always draw a line through it that's parallel. All right. Now, guys, if you look, let's see here. angle 1 and RPW form a linear pair. So we said this angle and this big RPW. So that is angles 2 and 3, guys. So please notice, you cannot say angle 1, 2, and 3 form a linear pair because that's not a pair. That's a schwa. Okay? So a pair has to be like angle 1 and then that big RPW angle. Now, why can I say that? Because I know what a linear pair is, definition. All right? Now, from here, you say they're supplementary. And why can I do that? If two angles form a linear pair, they're supplementary. Now, guys, I need to break up that big RPW, so that's the next thing I did. I said that equals 2 and 3. And we should all know why. Angle addition postulate. Good job.
I was going to say that, Dr.
I know you were. I know you were. You were just waiting on me.
I was just eating a lollipop.
Yep. Sure thing, buddy. Oh no, I can actually move that down if I wanted to. I mean, it doesn't actually matter, but I'm going to put this equals 180 first.
I can do it.
It doesn't matter. You can throw angle addition postulate anywhere you want, really, because it's not like you put something in the wrong order. It's just that's the order I like it. All right. Let's see if you think you could get the rest.
I'm not even done writing it down.
No, I know, but I mean, it's on there.
Dr. Frick, I can barely even
I
see
don't
the
know
board.
about that.
Okay. No, I'm okay.
Put on your glasses.
No!
Put on your glasses.
I refuse.
You just said I do.
I
know. Enzo, it's also on your paper, babe.
Oh,
Put on your glasses.
Isn't it? Oh, just kidding. I meant to do that. That is my bad, guys. I know, because I was thinking, I was like, why didn't they just put like 1R, 1S, 2R, 2S? JK!
You can't even deny
Okay, the next thing I'm going to do is I'm going to substitute.
What?
Be nice.
This is a big
All right, I'm just going to put it down and let you.
Thank you.
Dr. Frick, can I take a picture and copy
That-
my video?
That's fine.
Doesn't
Yes, if you want to take a picture, you can.
Yeah, I'm totally going to copy it now.
You don't have to walk up to the front.
Yes, we do.
Enzo, you don't need a photo shoot, babe. I'm surprised you're not doing, yes, darling, yes, just like that.
Yes.
Yes, work it. Okay. Okay. All right. Obviously, guys, I would never ask you to do that from scratch, but you could be asked to fill in a step, like it's one of those where like a step is blank or a reason is blank. Colin, don't be that guy. All right. I throw my hands in the air. No. Okay.
Don't be that guy.
All right.
You're not that guy.
Okay, guys. All right. So this is pretty much the last big idea. Exterior angle theorem, guys. So exterior angle theorem. The measure of the exterior angle of a triangle is always equal to the sum of the two remote interiors. Guys, if I tell you I'm going to move away to a remote location, obviously that doesn't mean I'm going to New York City, okay? that means I'm going out in the wilderness somewhere where no one's around. Just like a remote control, allows you to be away from the device you're using it on. Remote, yeah, there's a reason they name things things. Mind blown.
So why do I have to walk?
So remote means away. Remote means away.
Why is it connected on?
Okay? So, all right. So an exterior angle is always going to equal the two remote. So that means away, the two interiors that are away from it. So let's look at this. Guys, I just want to show you this real quick. Maybe you don't know, so I'm not trying to be cute. This would be the exterior angle. Okay? So anytime somebody said it looked like an old school golf tee, like not a golf tee, a golf flag on its side. So they were like, look, that's like the flag in the golf hole on its side. Anytime it's drawn, the triangle is drawn with an offshoot like that. That offshoot can be in any direction. That forms an exterior angle. Okay, so what this is saying, guys, is this exterior angle right here is always going to equal that and that. That was supposed to be a Y. It did not work. Okay? So the exterior angle, wherever it is, always equals the two that are not connected to it, the two that are far away from it. So, guys, if my exterior, let's say an offshoot went this way, then it would be this one equals that one and that one. Okay? So it just depends on where the exterior angle is. All right? Now, guys, you do not have to worry about this proof. I just wanted to show you, this is a good example. This is a good example of why people use this is a good example why people use a flow proof. This is a good example of why people use a flow proof, because this one would be.
No, I was putting it back.
If you look, the dark gray is the given. And then based on the given, they were given a triangle. So they could say the angle sum theorem, say you add it up to 180. Then they said that CBD and CBA formed a linear pair. That means they're supplementary. That means they add to 180. Now that they both have equals 180, then they come together by substitution. No, I know that's not you that time. All right. And then you subtract. And then if you're me, apparently you leave off angle signs in your proof. So anyway, but this is a good reason why people use flow proofs, because it allows your thoughts to be separate and then come together at this right time. All right, boys and girls, these, all right, if you need clarification, you're looking for angles 1, 2, 3, 4, and 5. The other numbers are angle measures. Okay, so I'm looking for the measure of angle 1, the measure of angle 2, the measure of angle 3, measure of angle 4, and the measure of angle 5. Now, boys and girls, my hint to you is do not go in the order that they give you the numbers necessarily. You just go with what you see first, but use what you know about all the properties and what you automatically should know anyway, and try to find me those angle measures. I'm so proud of you.
Never mind.
Also, still proud of you. You should be able to use what we've just talked about to find 1 and 3. 1, you're using it straight up. 3, you're using like a converse of it.
Oh, hold on. I got you.
Oh, I know it. I got it, Doctor.
I'm aware. I'd like you to go do your math.
Oh, he got you there.
Got you there.
He got you there. Go do your math.
y'all stop throwing me off.
How am I gonna
We're
do
not
this?
even
I want to use a protractor.
You're fired.
You're fired.
Didn't Einstein use a protractor? That was great.
I'd rather go to the doctor.
Oh yeah.
They use tractors.
All right, because I'm recording this, I'm going to go ahead and go just so that people aren't,
You're recording this?
Yeah,
For the grant?
you're still fired. Okay. Okay, so guys, to get angle 1, you're going to use that exterior angle theorem. All right, the two remotes are 46 and 65. 46 plus 65 gives me 111.
111.
All right,
Mine was- Oh, we need to find 5.
that's where that came from. Now, angle 2 forms a linear pair with angle 1, which means it's supplementary, which means it adds to 180. If I know that part of that is 111, that means that the other one, it has to be 69 degrees. Now, angle 3, guys, you're still using the exterior angle theorem because I know that 82 plus this angle here has to equal 142. All right. So I need to figure out what this angle is to make it add up to 142. So 142 minus 82 is 60. I knew you were.
No, I was though. You just beat me to it.
Now, guys, angle 4 should have been the easiest angle on here because it's vertical, 60. And then finally, angle 5, use your triangle sum theorem. If you know what 2 and 4 are, you know that 5 has to make it add up to 180. All right. Yep. And it's going to be 51.
Oh.
Anybody have a question about those?
Oh,
Give me 1 second. Okay.
I'm gonna throw a honey bun.
Guys, I need you to pay attention. This is the first time, I think, that you've been introduced to corollaries.
No.
Okay. So, not coronaries, corollaries. All right? Guys, a corollary means you're not even special enough to warrant being called a theorem. Like, it's so easily proven that they're like, eh. It's in between, it's like in between a big duh and a theorem. So a corollary, guys, the acute, it's so easily proven. So the acute angles of a right triangle are complementary. Well, duh, if it has to add up to 180, and I know part of it's 90, the other two have to equal 90. That's why that's a corollary, because I literally explained that in a sentence. Now, corollary 2, there must be at most one right or one obtuse triangle in a triangle. That's once again, obtuse or right has to be 90 or above. Y'all, if there were 2 obtuse, you would have a negative third angle. If you were 2 right, you would have a negative third angle. That's impossible. All right, so that's why they're corollaries. Now,